From ContainerDays Hamburg, this video is proudly presented by Dux IT.
I'm here to talk about how platform engineers have a good opportunity at their hands, because now with this whole new developments in AI, that how they can really improve their processes, they can boost their efficiencies, but also there are all these developer communities, all the other people are wanting to try AI in their organization, and they are the one actually enablers in their organizations to use these new tools and new technologies, and like what kind of transition that they need to go through, or what kind of changes or what kind of new technologies they need to adopt. I want to talk about this a little bit. And I'm a platform engineer, DevOps, SRE, whatever you call. Like, I'm coming from that background. And this is going to be a little bit of based on my own experience, based on my team in Red Hat, like what we are doing. My name is Cansu. If you've ever seen me talking before, I always talk about platform engineering, how to build high-performing platform teams, how to help organizations to build platforms that fit for purposes, the platform as a product, all the things that Artem actually talked about before me. So I'm not going to dive into those things, but I do love talking about those things. So if you ever want to chat about these things, I'm here today, tomorrow, so please find me. So today I'm going to focus more on the AI platform side of things, and we're going to do it a little bit on the story side of things, because now that this whole GenAI hype started like 2 years ago, like 1.5 years ago, some of you also maybe heard the same questions within their organizations. Like, there are developers, there are people are coming and asking, like, can I get some GPU, please? I want to try this model. I want to deploy this model. Or can you please deploy this model? I want to experiment something. Like, everybody is coming up with these ideas. They're like trying to see what kind of vector database is better for their use cases, maybe, or which model is much suitable for their experiments, for this POC they are doing. And we heard the same things within Red Hat as well. Like, there are all these people want to try AI, want to just get their hands on a little bit, and like just to see if that idea of theirs are really viable, if they can really build some applications with AI as well. So as a team, we heard these questions, and also as a team, we wanted to have an experience of what it looks like to manage an AI platform at scale. So this is based on a real story, actually. So it all started like I guess like 2 years ago, that us as a team sending out a message to our boss saying like, hey, I think we should have a cluster with OpenShift AI, which is our AI platform. Like, we should have this platform available to all Red Hatters. This would also show us the first-hand experience, what it looks like to be a provider like OpenAI, like all the others. And then we can let everyone to use it, so people don't have to worry about really first install the Kubernetes cluster, OpenShift, and OpenShift AI, all the GPU operators, all those kind of configurations, and then deploy the model and then start doing the experiments. He said, sure, great idea, go ahead, use our cloud budgets. And then we felt like, yes, like we got the mission, we can do this. So we put a cluster up. It's if anyone familiar with OpenShift, this is an OpenShift console. We have this cluster, and it is open for every Red Hat employees. Like, everybody who would like to use this, they could just log in with their Red Hat credentials, and they could just use that. And the cluster has some really good GPU-powered nodes. It was available for everybody to use. They could just use it. All is well all is well in the end. We got this message from Chris and says like, hey, I hear you have an OpenShift AI cluster available to all Red Hatters. Can I get some GPUs? Or like, we feel like a hero in the story. Yeah, like, just go ahead. And sure, go ahead to this link, use your credentials, you can use it. And when he lands into the cluster in the OpenShift AI side, he sees some options that some GPUs are available for him. He could use it, some really big GPUs as well. Just next, he can do things. And soon, quickly enough, within the company, the word started getting out, and people started coming up like, yay, free GPUs and free GPUs. Everybody was like in the bootstrap, like, just come in. Well, Red Hat has 19,000 employees at the moment. So think about that. No good deed goes unpunished. So Matt reached out and say, hey, there are no GPUs left in your cluster. What's going on? Like, that's strange. Let me have a look at it. So go to cluster. It's not OC, kubectl get pods. You see that like there are 7 different namespaces, the 7 instances of the same model. Everybody deployed that Granite 3 8B at the time, and like everybody just deployed it, and we were like, wow, everybody's really into this thing. Like everybody is doing like using it, and we hop up onto the monitoring on the GPU usage dashboard, and the GPUs are like dead. Actually, they were not utilized and not used. And we're like, okay, that's, well, it turns out 7 people deployed the 7 same models. That was our max with the cluster at the time. Nobody is using it. So the view is like this. It's like 7 people going to consuming 7 GPUs, and those GPUs were idle. So that's not good. So we feel like, oh my God, what have I done? 7 GPUs, the cost on AWS, I think about that. So we sat down as a team, we said, there's time for a new strategy. First, we calmed down, we forgot about the cost. Whatever happened, happened. So we came up with some ideas, and then we left that ideas. So we could increase the max number of nodes on the autoscaling side, but then what's going to be your max? There are 19,000 employees in Red Hat. And then we said that, okay, we can set quotas for people so they cannot consume many GPUs. But again, even 1 GPU for people, there's 19,000 employees. And then, we could split some GPUs, like we could use MIG, and we can just hand out some slices at least. But then some models will be too small to fit 1 slice, and then people will use this couple of slices, and then the same thing again, plus all the head over because of the slices. So the ideas we kept, so we said, we're going to take back all GPUs. There is no GPUs for people anymore. And we deploy each model once. And we said, we're going to put an API gateway in front of these models and let people access those models through API gateway. Magic, profit. So, and then we started calling these models as a service. And this is basically like putting an API gateway into any API, basically. Nothing new. Like every organization has an API gateway at the moment. But we didn't see that at the time. We already had API gateway. So it was like, that just makes sense. So instead of doing this, we started doing that. We are like, okay, like now that everybody needs to go through API gateway and then access the same model. So just 1 GPU utilized. So now that next time someone asks about us, hey, can I get a GPU? And like, maybe, what is it for? And just, I'd like to deploy Granite just to try something. I was like, Granite again. We're like, no need. Just head over to this API gateway, just log in, get your access, and then you are good to go. And he was like, wow, that's even better, because he doesn't have to worry about deploying the model anymore. So you took that actually overhead, you took that complexity from the person, and then you just give them what they want, because what actually that Matt wants to do is to start building actually business applications. That's what his goal, that's what he needs. So we just add Matt to the list, and then he starts consuming. And next day, someone comes and say, like, do you have Llama 4 on your model as a service instance? We're like, not yet, but you need it. Yeah, I want to test it out. Sure, I'm on it. So we just make some magic, and Llama 4 is behind the API gateway, and then we give access to Joe through the same API gateway, and then they access that. So just to recap, what changed as a platform engineer in my life is that I have now new terminology in my daily life. I have just new type of workloads. Now I'm talking about models and GPUs, and embedding models, maybe vector databases, etc. But what stays is that I'm still playing the enabler role of my organization. I'm still lowering down the entry barrier of the platform, of this whole complex new domain, and just let the people to actually do whatever they would like to do. So I'm still abstracting the complexity. It's just this time, it happens to be an AI-specific complexity. So let me see if I can just quickly show what does it look like before, or let's talk about onboarding and actually showing that. So whenever you've been in an platform engineering talks, you'll definitely hear that onboarding topic, like onboarding the new users, onboarding new applications, it's basically becoming cliche in that point. And I really love this quote from Sir Terry Pratchett. And the cliches become cliches for a reason, because they are your hammers and screwdrivers in your toolbox. Onboarding is a must topic that you need to tackle in the platform engineering. And when it comes to onboarding, the most important thing is about that, like, you need to make it as easy as possible, as self-service as possible, and as standard as possible. So let me just switch over here. Yes, this is one of our model as a service instance. As I said, that you could do with any API gateway, like 3 scales from Red Hat. This is based on Light LLM as an open source project. There is Kong, there are others if you want to use. So we built this based on Light LLM. We coded a UI for that. So as a developer, what I do is that I come here, I can easily browse the models, what is available. Like in this case, there are a couple of models here as an example, like DeepSeek, Granite, Llama 4, Mistral, etc. And all I need to do is to just go one of them and subscribe. Well, apparently I already subscribed to this one. So let's try this one. So maybe I want to try some coding assistant. So this is the instruct model. So I can subscribe to a model. And then after I subscribe, I can create an API key. Let's say that ContainerDays 2025. I select a model from the list, and like the API key. So it gives me a key, it gives me an explanation. If I go in here, I guess, yes, we also put an example so that the people who want to use this can start by, just have an initial example for like as an API documentation type thing. So what I can do is that I can just switch to a terminal. I can just paste this, and then let's see. Oh, come on. Just replace the token with the token that I have from my model as a service instance. Let's just copy this again. And hopefully, if network allows, I might get some answer. Yes. So all I just say is that, like, just, hey, come on, where did you go? And then it's something like, hello, how can I assist you today? Blah, blah. That's all. As a developer, I don't have to worry about where this model is running, what are the parameters, what are the runtimes, and etc. that I need to do for this model. Because as a developer, all I want is to actually build those like AI-enabled applications, those like smart AI-infused applications. So that's good. You can lower the barrier. So what changes that? Oh, sorry. I'm going to go, one slide is missing. OK, let me just talk about this. As a developer, I'm helping developers to, now that get an access, an API key, and a token. But the success actually comes from that when everybody uses AI. Because if you think about that, not everybody in your organization are able to just hop on a terminal and start writing the curl commands and start actually building an application. You have finance, you have HR, you have all the other parts within the organizations that want to actually use AI. And not everybody is as lucky as to swipe a credit card to an OpenAI and start using their models. There's this whole data governance part of things, the security part of these. They are sovereign data sovereignty part of things. So you need to actually provide this kind of capabilities within your organization. So again, you can think about yourself as the enabler and actually build an abstraction layer on top of this one, on top of this model as a service. And this is just an example application we built to show what is possible. And you can actually make the self-service one step further and then build some sort of a glue code between this application and your model as a service API gateway instance, and automatically fetch automatically subscribed, create an API key, and provide people some services. So, for example, in this instance, we have these services for anything LLM as like a chat box where you can upload some documents and start chatting with your documentations, like maybe a code server ID for developers that already comes with a coding assistant configuration, because I have an instruct model in my model as a service instance. Now that developers don't have to worry about how they can enable that kind of assistant within their IDs, I can just provide the IDs. Or a stable diffusion for the marketing, for example, it's a vision model. They maybe want to create some, I don't know, like logos type stuff for marketing events. They can just use that. And all they need to do is to just pick what they need, give it a name, say like, let's say ContainerDays, LM, let's say. And then instead of waiting this, we can just jump one existing one. So this is Anything LLM. I don't know if anyone has used it. It's open source. You can download it on your desktop. Just provide some credentials for the models, and you can start just chatting models. So when this is running, they will see a UI like this. Just creates a workspace for them. Oops, come on, network. And then just start, just chatting. They didn't have to worry about where the model is running, which model is it, how to configure the Anything LLM. Everything just happened automatically, and those are credentials automatically created in their model as a service instance for them. So let's go to the slide deck. Or actually, I want to show the STXL as well. So this is the stable diffusion. So you could just prompt anything, and then you can just prompt something to get some image generation. So as an editor, let's say I want to have a red fedora, and then it'll start building the image. So there's a bit of a risk with this one. It has some built-in safety check by default, but it could basically generate anything. If you are maybe you do some prompt injection and stuff. So we put in a guardrail into this one. So I'm going to come to that now. Because, let's go to the slides. So for the onboarding bits, what stays that your onboarding expands not just the traditional applications now. Now it also includes AI use cases. But again, I'm saying the same things again, but your role as an enabler of dev experience, like the principles of self-service, the standardization, the traceability, the whole the authentication bits, those are still stay the same. Those are still very relevant. The whole platform engineering bits are still very applicable in this new domain as well. So apparently I put the slides the real success comes when AI is not just for developers, but it's just for everyone. Everyone wants to use AI, and you could just enable that. So you can enable your whole company. Your just audience gets bigger when it comes to enabling people. Guardrails. When you are providing some service, you need to ensure its security, its safety, especially when it comes to AI. So a colleague of mine, Robert, he just he did this guardrail bits for the vision model. So he let me know that he enabled the guardrails, and I was like, oh, that's cool. Then I can test this. And I was like, oh, sure. So I'm going to test this. I'm not sure if how well it is going to work. But one of the discussion we had was how am I going to actually showcase this one? What should I write to actually block this? But what he did is that maybe as a Red Hatter, we don't want to have we don't want our model to generate a green fedora. So what he did is that I can talk about the details of it, but basically that he embedded the guardrails in the whole system. That's why that we are blocking the image before it starts being visible for you, and now it is checking some sensitive content. It does some sensitive content check, and if it doesn't pass, damn it, it passed. I actually had a video that it actually doesn't pass. So sometimes it doesn't work, but it was supposed to say something. I knew that might happen. This is the whole, what is it called? The word doesn't come to me at the moment, but it was supposed to say something like, sorry, the image generated. Maybe he's experimenting something in the back at the moment, but it was supposed to say something like, sorry, the image generation has been blocked and not able to do that. I tested before I come, but it's the nature of LLMs. It's not stable. So what happens actually in the back is that because you are providing a service to a whole company, you need to ensure its safety, right? There are a couple of things that you could embed into the process, just like we did when we are putting the containers, putting the applications into production. You still need guardrails in here as well. So there are a couple of ways to do that. In here, we check the prompt, if the prompt is safe, and then we check the resulting image, if the resulting image is safe, and then decide whether we want to show this to the end user. So there are new responsibilities come to your platform for AI-related responsibilities. But again, the guardrails, internal tooling, the security and check, we've done these things before. It's pretty much the same principles. But who is keeping track? All those things are happening within the platform. So there's no such thing as a free AI lunch. So we need to deploy these models. We need to manage this platform as GitOps. Our API gateway keeps track of like who is using how much of this platform, which models, and then we could actually embed the cost tracking, because we've been doing this for the traditional applications, like which namespace consumes how many resources. Now that the cost management discussions goes into more like the GPU cycles and the number of tokens consumed and so on. So what you can do is that GitOps is still very important in this domain. It's not going anywhere. It's not going to go anywhere. You deploy the models as well through Argo CD. So what happens is that you define a model. It's in this case, we are using Kserve. It's like serving runtime. You put in Git, Argo CD syncs it to the cluster, and then on the cluster, you're able to see that there are like all these different models that are deployed. Secret management is still very important. There are all the other bells and whistles that you need to have in your AI platform. If, for example, the model registry is an important thing to keep track of which models, which version you are actually deploying to the cluster in order to keep track your experiments, keep track of which model you use, which worked and which not. And for example, a model registry would require some secrets. For example, in this case, we've been using for that cluster that I showed at the beginning, using the external secrets. It's still very relevant. And I wanted to put the link of this whole GitOps repository, because that cluster, as I said, it is available for like 19,000 employees. So it's a real battle-tested cluster. And in this repository, we have all the things that we've been doing from the moment that you install the cluster, all the certificate setup, all the storage setup, everything up to the last application that I showed. You can find many things there. It's just in case that you are interested, in case you want to get some inspired. That's the link of that cluster. Then we have the API gateway, right? You have API gateway and it tracks everything. So for example, that you see how many people have been using that, like recently, how many signups you have, and then you can actually drill down for a specific user, like how many API keys that person created specifically, and then you can actually go even more drill down for how many tokens that person has been consuming for that specific model. So you can go down this traffic, because as a platform engineer, you are not really interested on just one person. You could do that most of the time when the person has a problem, or like when you need to some specific reports or something, but you need to have an eyes and ears on overall in the cluster and like how many models are using, so that you can make the decision of that this model has not been consumed much, but those GPUs are very, very expensive resources. So you can make the decision of like, I am not going to, maybe decommission that one, and there's this new model. I'm going to use that the same GPU to deploy this new model. So you can actually have a traffic, and all the API gateways provide that. These screenshots are from 3Scale. And then you can just look for the number of tokens that are being consumed over 24 hours or over 30 days. And then you can say that who is using it most. And then, I don't know, maybe would be an interesting statistic to see actually whoever is using like 37,000 tokens and over 24 hours. That's interesting. Who knows what he's doing. And then you can do the cost tracking. You can just like randomly put some numbers there in order to have some charge back to the teams. Maybe use the same pricing as the other companies, as the SaaS offerings, or you could just put random somethings, and then you can have more eyes of seeing like who is consuming, how much consuming one. And then you can cap that resource if your API gateway is capable of doing that one. So again, to recap, what changes that you still apply GitOps, secret management, monitoring, chargeback, all the important bits. it's just to a new types of workload, just to a new types of metrics. So it's still relevant. What stays is the whole core platform engineering principles. You need to learn new tips and tricks, like you need to learn new tools. Like now that Kubeflow is going to be in your conversations, Kserve is going to be in your conversations, Kubeflow notebooks, Kubeflow pipelines, and all these kind of things. But still, automation, standardization, governance, observability, these things are still important and still relevant in order to have a scalable, manageable, reliable AI platform. So, reflecting on our journey. We didn't need to become a data scientist. Time to time, we need to have a better understanding of their language in order to provide them a good automation and in order to provide them the good service, the right service. But most of the time that recently with the GenAI rise, you are mostly interacting with the AI developers or the developers who are going to build new applications with AI agents, for example. So you don't really need to scare of this domain. I've seen that people are mostly scared when it comes to AI, so you don't have to. But your background, your knowledge, your experience is still really, really important in here. As I said, there are just new tools are coming from the open source domain. And we didn't really need to train a model from scratch. There are all these good open source models. You just need to bring them in and able to serve those models. We used our platform engineering skills to make an impact within the organization. And in the end, you just enable AI developers and data scientists in order to use AI to do the business critical work, the work that the work that actually brings the value for the organization, for your company. So platform engineering work is indispensable, but it's not that visible for the end users of your organization, but it is essential, it has to be there. So I guess, I'm quite early, I went too fast. So with that, I want to drop you a couple of links that might be useful. Some of them are the repositories of the tools that I showed along the way, like model as a service, as an implementation, the AI Studio one where you can provide different services for the different part of the organizations, not for developers. We have a blog, AI on OpenShift.io. It is where all the Redditors are shared there, basically the experiences or share the new stuff that they do with AI, around AI. And I think the most important thing is that sharing our lessons learned so that you don't have to go through the same pitfalls, go through the same mistakes. So this could be quite useful. And there are actually more to that AI Studio demo. I wasn't really sure if I'm going to have time to show that. So there is Parasol AI Studio Arcades. It's like a click-through demo. You can just go and deep dive a little bit off to see what kind of things we can do with that. Just as an inspiration, those things are all like an abstraction layer on top of the platforms. So, and with that, I want to thank you. So.
Are you scaling the models somehow up and down to save costs?
Well, we do for some of them. Actually, initially we thought about this, but then we are a global company. It is like we have employees in EMEA, but we have also employees in APAC, in Australia. So we don't really have the good time to shut a model down. But what we did is that we identify still like sometimes the models are not super very useful. We are using some batch jobs. For example, we have this process where there's an open source tool called OpenHands. Maybe you've heard about this, where you hook OpenHands into a model, and OpenHands can go through your repositories and basically do some stuff based on it can look at the issues, work on the issues, and raise some pull requests, or it can just go through READMEs and just fix typos or make everything is in the same format. So we run those kind of batch jobs among our repositories at some specific times where we know that GPUs are not very highly utilized. So we started doing that instead of turning off the models, because as I said, it's a global company. You never know who's going to need the model when. So, not exactly.
So the next question is, which AI ops and ML ops tools are you using in OpenShift AI?
So We have so OpenShift AI for ML, predictive AI and GenAI. For predictive AI side, well, actually for both sides. So we have Kubeflow notebooks for the Jupyter Notebook or Code Server or RStudio. So it comes out of the box like as a ready IDE. As a data scientist, they can self-serve and get a notebook and start using that. We have model registry to track the models. We have experiments. From Kubeflow pipelines, we have Kubeflow pipelines itself as the Argo workflow backend, as the engine for the training pipelines. This could be the fine-tuning pipeline, or this could be a regular machine learning training pipeline. We have KFTO, Kubeflow Training Operator for the training jobs, for the distributed jobs. We have VLLM as the LLM engine, is the runtime. Is the performance runtime. What else we have? We have monitoring, but basically it's the Prometheus collecting the metrics, and if you want, you can just put a Grafana dashboard on it. What else? So OpenShift AI is an abstraction. OpenShift AI is an extension of OpenShift. So every good thing that you've been doing, everything that you know from OpenShift side, from the containers, that also applies to OpenShift AI. So you could, one of the ways that we are deploying the models is making models something called model car from, I think again, from either Kubeflow or Kserve, I'm not sure, but basically storing the models as an OCI artifact so that you can apply all the good things that you do to OCI artifacts. Like you can version them, you can scan them, and you can distribute them. So we are using model cars to deploy the images so that we can make sure that whatever is run in the test environment is in the production environment, and we can sign them, we can run SBOMs and attestations and all this kind of stuff. Or like you can use Tecton pipelines as well if that's your working. For some multimodal approaches, we have Service Mesh, Istio, and Knative, and then Kserve on top of Knative. So the greatest value, the biggest value of OpenShift AI is that you don't have to do the glue work between all these different open source projects. It's already done by us, and it's just open as well. You can just give it a try. It's out there. Open Data Hub is the open source upstream name of OpenShift AI. So OpenShift AI gives these like collection of tools and a unified experience, basically. So there are a lot of open source tools under the hood, a lot of open source projects that as Red Hat we support.
Can you also use the models with specific SLOs?
You could set an SLOs. It really depends on your if the SLOs means the service level objectives, if I assume. So it is again dependent on your use case, whatever your objective is. That you could set that, you could start tracking those metrics against your SLO target, and then when you are actually start burning your error budget, you can be notified that. We have monitoring and alerting system as well on OpenShift, so you could. It's totally up to you. Even though this platform that I just showed is not like a production because. We are using it mainly starting for learning, and then it started becoming something that to show our customers like as a demo to show the value, to show what kind of things are possible with AI. So it has to be up and running for all the time, because you never know when a salesperson showing that to their customer, like I did basically to you. So we set some actually monitoring on top of it, and not like a really serious SLO type thing, but we aim to a really high availability so that we don't really make any red hatters in a hard position at a time. So.
And the last question is, do you allow users to fine-tune models?
Yes, we have fine-tuning pipeline. It's called Instruct Lab. I guess it's using a specific Instruct Lab of something alignment. I forgot the name now, but use a specific algorithm to, not LoRa, something else, I forgot, something alignment lab method. But it comes with that as well, and it lets you to define your domain knowledge. Let's say whatever the topic that you want to fine-tune the model, you want to bring into the model, it allows you to create those informations as in a YAML format. It also has the capability to turn your PDFs, turn your documents, transfer them into the YAML format, and then you just store them in a Git repository or somewhere, and then you just point to those sources and your model, and it starts generating some synthetic data based on your company data, based on your domain, because that amount of data not enough for a big model, for a large model to learn. So it generates for synthetic data. It actually grades those synthetic data to show how good to make sure they are good, close to their originals, and etc. And then start fine-tuning the model. So that comes out of the box with OpenShift AI. So if you have enough GPUs, why not? So.
That was the last one. Thank you so
Yay.
much. A big round of applause.
From ContainerDays Hamburg, this video is proudly presented by Dux IT.